Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see a Leetcode question number 2696. Minimum string length after removing substrings. You are given a string S consisting only the uppercase English letter. You can apply some operation to this string where one operation can remove any occurrence of one of the substrings A, B or C, D from S. Okay, return the minimum possible length of resulting string that can be obtained. Note that the string concatenates after removing the substring and could produce new AB or CD substring. So this is the most important key. Okay, this is the most important key. Fine. Then fine. We can see the example. See here. This is the example. Okay, what is the example? A B F C A C D B. Yes. Now, just observe carefully. What are the elements we can remove? We can remove this AB, right? We can remove this AB substring. Other than that, whether we can remove any other substring? Yes. Yes. What we can remove? We can remove the CD. Yes. Okay. Let me write again. They have told us, right? It will concatenate again, right? So F, C, A and B. Again, this AB. So we will take this. Now what is left over? Left over is FC. So what is the length of it? The length of FC is 2. Yes, is 2. So this is the example that's stated in the code. Fine. Now let me take this example. AC, BB, D. Whether there is any sequence like AB or CD. No, no, there is no sequence. So what is the length after removing? It is 5. So this method is so simple, right? We are just traversing this entire string. If there occurs any AB or CD, we will remove this. And then again, we will check for any other. If there occurs, we will remove it. When there is no such string present in this string, then we will return the length. So this is the approach. This is a simple brute force approach. Okay, simple brute force approach. Okay, can we do in any better way? Okay, let us see. Observe this carefully. We are just concatenating, right? We are just concatenating the string so that we can say the previous element if it is equal to the current element. Just take for example, if this is the case, okay? If this is the case, then if I split this string as two, this previous element is equal to this. Sorry, it forms the if the previous element and the first element forms a sequence, a substring that's stated in the question, then we will remove this, right? So why can't we use the stack, which means last in first out, right? Why can't we use the stack? Fine, just use it. But how to use it? It's simple, okay? So don't worry, just put a stack. Just put a stack. Now let us take this example. What is the first character that occurs in this example? A. Whether the stack has any element? No. Just put A. Just put A then. Okay. No, it is B. Okay. Whether the stack contains any element? Yes, A. Okay. Now comes B. If I put B here, it says that the substring is AB, right? Stack top is A. Now it becomes B. So you can say it is a substring we want to remove, right? So just remove this A. Just remove this A. Now go for this F. Whether stack has any or no. Just put F here. Okay. Now go to the C. C. So FC is a substring we want to remove. No, no. So put C here. Okay, fine. Now again this A. Okay. Now put A. Whether CA is a substring we want to find. No. So directly put A here. Okay. Now C. Now AC is a substring we want to find. No. Just put C. Because A is a stack top, right? So put C. Fine. Now D. No, here comes. Here comes. Top is C. Okay. Here comes D. CD is a substring, right? So we don't want it. Just remove. Just remove the C. Fine. Now here comes B. B. Now stack top is A. Whether AB is a substring we want to remove. Yes. So remove it. So remove this A. So what is the leftover string? It is F and C. So FC is a remaining string, and what is the length of the stack? I can say this length of the stack is 2. So it is the output. Fine. So what is the time complexity and space complexity? What's the time complexity and space complexity? I can say time complexity is O of n because we are transferring to entire string and we are just putting and taking the entire string inside the stack. So it is O of n. And what is the space complexity? It is also O of n because we are using what auxiliary space called stack, right? Okay. Whether we have any other a better approach? Yes, we have a better approach, but that better approach can be done in only in a language where the string are mutable. Okay, in only in a language where string are mutable. It means string can be changed or modified. Like these, the languages like C++, Java, C, like that. We cannot do this in Python. Understand? Because in Python strings are immutable, we cannot change the string. Okay, so in Python the stack approach is the optimal approach, but still we can do this in a two pointer approach. The second approach is what? Two pointer approach. It is a bit complicated, but still if you come up with me it will be more clear. Okay, just see here, let me take the example abfc acdb abfc acdb. Okay, now just observe this carefully. It is quite difficult. Okay, it's quite difficult. First of all, I will take a f pointer which is equal to 0, and then also a I pointer which is also 0. Okay, just come up with me. Here is my f and here is my I. Here's my I. Okay, 0 1 2 3 4 5 6 7. Fine, understand? Here is my I. Fine. Now just check whether this this I is a, right, with f minus 1. F minus 1 is whether there is any previous element here. No. So don't do anything. Just keep that I inside that f. If you don't know why we are keeping that I inside that f, just wait. I will say in the future. Just wait. Okay. Now move this pointer. Move both pointers. So move both pointers. Yes. Now again listen carefully. The previous element of f is a and the current element of I is b. So it means it forms what? AB. It forms what? AB. So it won't be my answer, right? So we will take this f. Take this f and keep here. Keep f here. So what we have done here, if the ith element, is equal to what? F minus 1th element. Okay, then what should we do? We should do what? F minus equal to 1. Right? Okay, fine. Now move I here. So f is 0 and I is what? 2. Fine, clear. Now again there's no previous element, right? If this is not a case, then what should I do? I should replace this f to this a. Why? Because this AB cannot be a part of my answer, right? This AB cannot be a part of my answer. So I just moving towards right side and making that element as my element now. Okay, now this A is replaced by f and then move this f pointer to this one. Okay, so now f pointer is 1 and I pointer is 3. Now I pointer is here. Now again check. What is f minus 1? It is f. Okay, what is I? It is c. Fine. Now check whether this is forming a substring like AB or it forming a substring like CD. What is a substring it forms? It forms a substring called FC, right? It forms a substring called FC because f minus 1 is f and I is C. So it forms substring FC. So it should not be removed, right? So we will replace C here and move this f here and move this I here. So where is my f now? At 2. And where is my I now? It is at 4. Up to here, clear? Now again look carefully. What is f minus 1? It is C. Okay, so f minus 1 is C. And what is I? It is A. So CA is a substring we want to remove. No. So don't remove it. So just replace this A here. So replace A here and move this f here and move this I here. So what is my I? I is 5. And what is my f? F is what? 3. Clear? No. Again Again, what should I do? I should check whether what is my f minus 1? It is a. What is my f minus 1? It is a. What is my I? It is c. C. AC is a substring we want to remove. No, no. So don't do anything. Just replace this C to here. So this C is replaced as C and move this F here. S and move this I here. Understand? Understand? Now again, just observe clearly. See here. What is F minus 1? It is C. F minus 1 is C. What is my I? I is T. So this is a substring I want to remove, right? This is a substring I want to remove. So what should I do? Do the same method. Take this F and keep here. F is equal to F minus 1. So my F is already 4. So now my F is 3, right? Right? It is 6. Now I will move this to 7. So my I is here, my F is here, right? Again, again. Check with F minus 1 is what? A. F minus 1 is A. And what is my I? It is B. So B. Whether it's a substring? Yes, it's a substring, we want to delete it. Okay. So what we should do? We should shift this F here. This F here. So what is my F value? It is 2. Already it is 3. Now it is 2. Okay. Now what is my I value? It is 8. So my root gets terminated. Finally, what is our answer? What is our answer of F? It is what? 2. So it represents what? It represents the array length is what? 2 after deleting the all substrings. Okay. So this is a two-pointer approach. Fine. So what is the time complexity for this approach? I can say the time complexity for this approach. So what is the time complexity? I can say time complexity is O of n, and what is space complexity? It is O of 1, because we are traversing this array only one time. Yes, and we haven't used any auxiliary space. We are just using this string itself. Okay. Hope you understand this method. If you don't understand this method, just rewind it and just replay with some clarity. Now you will get some clarity. Just go up with another thing. Just see this method another time. But still, if you see the code, you will be more clear. You know what we are doing. Okay. Just see here. First of all, we can see the stack code. Okay. Just see this is stack code. Stack is equal to empty for I in S if stack and stack of -1 is equal to A and I is equal to B. It means the substring is AB, and same for the CD. If stack top is C and the current element is D, then it is what? CD. Then I want to pop the stack. Else I want to append the stack, right? And then at last I will return the length of the stack, right? Let me submit it. So this is an easy approach, I think. Okay, but still you want to know the two-pointer approach. It is more efficient. Yes, it is submitted successfully. Now let's see the C++ code too. This is an optimal approach. Okay. Int I comma f is equal to 0. Now for I is equal to 0, I is less than s dot size of I plus plus. Just we are traversing through the string s. Okay. If I is greater than 0 and f is greater than 0, we can put only f is greater than 0, because initially f and I are same rate. So it won't affect this condition. This condition won't affect. Okay. But still, I am just check for the value of I. Okay. If you don't want it, just remove it. And s of I is equal to B, and s of f minus 1 is equal to A. It means the AB substring is formed right now. It means AB substring is formed right now. What should I do? What should I do? I should move my f pointer one step minus. Okay. Or else, if I get D on my I and then f minus 1 as C, then it is what? It is substring CD. At that time, also I want to move my f pointer one step back, right? Else I want to shift my s of I to s of f. Why? Because now take for example, it is AB. Then currently my pointer is where? At A. Now we are just taking the other characters behind this AB and replacing them again and again, so that we can get the string and also the length. Okay. And also I'm doing what? F plus plus. Fine. Now at last I'm just returning F. Okay. Let me submit it. Yes, it is submitted successfully. This method is followed in next two problems in this playlist. I will give this playlist in the description below. Okay. Fine. Thank you.